You felt it before. Someone left you out of the group chat. Someone didn't text you back. Someone walked past you like you weren't there. And somewhere in your chest, something actually hurt. Not metaphorically, not poetically, but physically, it actually hurt. You probably brushed it off and told yourself it was silly to feel that way over something so small, but your brain didn't think it was silly at all. Your brain treated it like an injury. So what if being left out isn't just an emotional experience? What if it can also be a physical one, which goes through the exact same circuitry as a broken bone? Let's start with a simple video game. Not complicated, not violent. Just a ball being tossed back and forth between three players on a screen. In the early 2000s, psychologist Naomi Eisenberger designed an experiment using exactly this idea. She called it Cyberball. The selected participants lay inside a brain scanner, watching a simple animation of themselves and two other players tossing a ball around. For a while, everything felt normal. The ball came to them regularly. They were part of the group. Then, without warning, the other two players stopped passing the ball to them. The ball just went back and forth between the other two, over and over. The participants sat there, forgotten, watching a game they were technically still a part of, but no longer welcome in. Here's the strange part. The other players in the game weren't even real. They were computer-controlled. No one was actually playing with them in this game. The participants knew this going into the experiment. They'd been told explicitly that no actual person was rejecting them, and still, being excluded hurt them not just emotionally but also neurologically. Eisenberger, working alongside neuroscientist Matthew Lieberman, found that when people were excluded from the game, a region of the brain called the anterior cingulate cortex lit up. Sounds pretty complicated, I know, but to put it simply, this region is deeply involved in processing physical pain. It's the same area that activates when you stub your toe on a table or burn your hand on the stove. Have you ever wondered why heartbreak feels like an actual ache in your chest? This might be exactly why. Your brain didn't evolve with two separate systems in mind. There was no distinct system for either your social pain or for your physical pain, and it appears to have repurposed the same ancient alarm system for both and basically combined them. Think about what that means for a moment. Evolution is famously stingy. It rarely builds something entirely new when it can reuse something that already works, and the physical pain system was already ancient, already wired into every mammal, already screaming a single message. Something is wrong, stop what you're doing, and pay attention. So when early humans faced the threat of social exclusion, evolution didn't invent a brand new warning system. It borrowed the one already in place. That borrowing made sense once you understand what exclusion actually meant for your ancestors. Being cast out of the group wasn't a bruised ego. It was closer to a death sentence. A lone human in the ancient savannah couldn't outrun a predator the way a group could defend against one. They couldn't gather enough food alone during a lean season. They couldn't raise children without help, without allies, without a network, constantly watching each other's backs and making sure all is well. Anthropologist Sarah Blaffer-Hrdy has argued that human infants required an extraordinary amount of cooperative caregiving compared to other primates, meaning survival itself depended on staying embedded in a group. If exclusion meant death, then the brain needed a way to make sure exclusion felt unbearable, immediate, and impossible to ignore. Pain does exactly that. Pain is the body's way of saying this cannot continue like this. This is why a snub on social media, as small as it seems, can genuinely wreck your whole afternoon. Your conscious mind knows it's not life or death, but the ancient alarm system underneath doesn't know that. It's still running code written for a world of 50 to 150 people where every relationship mattered because your life depended on it. Psychologist John Cacioppo spent much of his career studying loneliness, and what he found should reframe how you think about it entirely. Loneliness, he argued, isn't just an unpleasant feeling. It functions like hunger or thirst, a biological signal designed to push you back toward connection. Just as hunger exists to keep you from starving, social pain exists to keep you from isolating yourself to death. Cacioppo's research went further, linking chronic loneliness to measurable physical consequences. These include elevated stress hormones, disrupted sleep, increased inflammation, and a weakened immune response. The body doesn't just feel lonely, it starts to break down as if it's under attack Because for most of human history, isolation genuinely was an attack in you. Even animal studies point to the same ancient wiring. Psychologist Harry Harlow, in a set of experiments now considered ethically troubling but scientifically influential, showed that infant monkeys separated from their mothers displayed behavior strikingly similar to physical distress. They clung, they rocked, they showed the same physiological stress responses you'd expect from an animal in danger. Connection wasn't a luxury for these infants. It was survival infrastructure. So here's the uncomfortable question. If your brain treats social pain like physical pain, does that mean you can treat it the same way too? In some strange ways, yes. A widely discussed 2010 study found that acetaminophen, which is the same over-the-counter pain reliever you take for headache, slightly reduced people's self-reported social distress after exclusion. The overlap between systems wasn't just neurological, it was deeply embedded into our chemicals enough to blur at the edges. This doesn't mean a painkiller can fix a broken relationship, but it does suggest something important. Your brain isn't drawing a hard line between the sting of a rejection and the sting of an injury. To your oldest neural circuitry, they're closer to the same category of threat than you'd ever guess from the outside, which raises another question. If exclusion registers as danger, what does connection register as safety? Literally, physiological safety. When you're surrounded by people who accept you, your nervous system quiets down, your stress hormones drop, your body, running on instructions written for over hundreds of thousands of years, reads belonging as evidence that you're going to survive. This is why a genuine compliment can feel disproportionately good, and why being ignored by someone you care about can feel disproportionately bad. You're not overreacting. You're running ancient software in a modern world. This software was created for stakes far higher than a slow reply or a quiet room. Modern life multiplies these old signals in strange new ways. You can now be excluded by 100 people at once without any of them ever meeting your eyes. This can come in the form of a post with no likes, a message left unread, and a group photo you weren't in. None of these were problems your ancestors ever had to process because none of them existed, but your brain doesn't know that. It runs the same ancient alarm regardless of whether the threat is a stranger with a spear or a screen that stays silent. Maybe that's worth remembering the next time you feel foolish for being hurt by something small. Then being left out of the group chat activates roughly the same alarm system your ancestors relied on to survive being left out of the tribe. Your brain isn't being dramatic. It's being exactly what it was built to be thousands of years later, still trying to keep you alive by keeping you close to other people. You felt it before. Someone left you out, and somewhere in your chest, something actually hurt. Now you know why. Your body was never speaking in metaphor. It was telling you the truth the entire time.